this is Mr. Robert Ayton, and this is my final project assignment for Concordia University EDGR 502, Developing Character Through Curriculum. Today we're going to be taking a look at ethics in the science laboratory, and more importantly, we're going to be taking a look at, first of all, a case study of tweaking the data to fit the result. We see this happen a lot in the science classroom, and this is something that we want to make sure that my students do not do, and make sure they're very cognitive of it. We're going to be taking a look at a case study of a thermodynamics lab, identifying an unknown using calorimetry. I love doing unknown laboratories, and the reason why is it kind of creates that CSI attitude in the classroom, and it creates a lot of problem solving, and also creates some moral issues and moral dilemmas that my students face. In this one, we're going to be taking a look at where in calorimetry we have two styrofoam cups, so we can do heat experiments, calorimetry experiments, and we're going to put a known mass of water. Something we know about water is it has a specific heat of 4.18 joules, that's the amount of heat that it can absorb, for every gram and for every degree Celsius that it increases. And I'm also going to give each of my students a known mass of an unknown metal. And as you take a look at this unknown metal, you might be able to see what it might be just by looking at it. My students will also be able to take digital thermometers and measure the initial temperature of the water, and then we're going to heat the metal up, the mass of metal, and we're going to place it in the styrofoam cup, and the water's temperature is going to go up, and the metal's temperature is going to go down because the metal loses heat, the water gains heat, and we're going to be able to find out the equilibrium temperature. And through some easy equations we've learned in class, we're going to be able to find out the specific heat of the unknown, of the metal, and we're going to be able to possibly even identify our unknown. Now in this case study, let's say we have two students, let's say John and Sarah, and John and Sarah are lab partners, and they end up finding out after their experiment that they've calculated the value of the specific heat to be 0.5425. But when they look in the CRC Handbook of Chemistry and Physics, they look and it looks really close to zinc, or much closer to zinc than it does to aluminum. But John and Sarah know that this metal that they have has a very low density. It looks exactly like aluminum. It feels like aluminum. It has all the properties of aluminum. And man, do they want it to be aluminum. And so what do John and Sarah do? They end up using the true value of the specific heat of aluminum, and then they solve. They go back into their data and they solve for the temperature final that they should have gotten. And they actually change their lab data to fit that result within their laboratory report so that their lab report looks spotless and it looks like it's going to get a great grade. And what I want to get with my students during this case study is this ethical? Is this the right thing to do? And the conclusions to this case study is that to report false data is unethical. It's wrong. We cannot do that within the science classroom. And if you think about it, what if those same ethics were done when making prescription medication? This might be the difference between saving a life and losing a life in the real world. And so that's something that we want to do in our science classroom. As part of that science laboratory is to report all data. It doesn't matter whether it looks like it's right, it looks like it's wrong. If it looks like it's wrong, we want to investigate the reasons for that experimental error. And sometimes the best innovations that we have and the best discoveries that we have is through data that doesn't look right. And so that's something that we want to make sure we do in the science classroom. Now, my goals of teaching ethics in the science classroom, especially in the science laboratory, is number one, to build a community of respect and accountability. Every time you're working with a lab partner, you want to respect them and you want to work to do the best job possible and to build that respect and accountability. Next is to help our students recognize moral issues, having that moral awareness when a moral issue or a dilemma ends up coming about. To help students analyze these moral issues with a positive ethical standards in place. We want to make sure we have standards that we abide by so that when we come to these moral issues, we can analyze them properly. And then to stimulate my students with a sense of responsibility, that they have a responsibility to do the right thing. And then last but not least, to help my students act on these moral issues with proficiency and competency. Those are my goals within teaching ethics within a science laboratory. My core personal values end up influencing my classroom and my students largely. And these personal values that I hold very dear are respect, integrity, and commitment. Those are the core values with which I live by. And the strengths that I have as a role model is I believe I'm a man of integrity that exemplifies excellence and hard work while having a passion and commitment to helping others achieve success. That's my goal as an educator on a daily basis, is to show the integrity and the character and the hard work so that it rubs off on my students so they end up having those values and those habits indwelt upon them. My future, the future that I see as a role model and educational leader is number one, to continue to mold my students to be young men and women of character and integrity, to having my example continue to influence them to do the right thing. Next is to learn how to better instill my students to develop the habits of delayed gratification. That is a goal of mine, to have my students understand how important this is to being successful, is to learning to not go after the immediate gratification, but do the hard work necessary to have delayed gratification. And last but not least, my overall goal is to stand up for biblical truth within the science community. That's the future that I see for myself as a role model and an educational leader. I've enjoyed making this final project and the knowledge I've gained from this class. So until next time, this is Robert Ayton signing off. Thanks for watching.